Good morning, everyone. Welcome to today's Lunch and Learn on data collection in manufacturing. We'll just wait a couple minutes for more people to join, and then we will get started. For those of you that just joined, welcome to today's Lunch and Learn on data collection at the point of manufacture. We're going to wait one more minute to allow some more people to join before we get started. Thanks for your patience. Okay, we will get started now. We are recording this session to send to you guys as a replay, so you can watch it back at your own pace, in your own time. But we just wanted to welcome everyone for attending today's Lunch and Learn titled "Why It's Time to Start Prioritizing Data Collection at the Point of Manufacture." My name is Greg Herzl. I'm the marketing manager here at CAI Software. I'll be your host for today's presentation. We welcome any and all questions. Please use the chat function that you'll find at the bottom of your screen. Any point during the presentation, just dump your question right into the chat there. We'll wait till the end. This isn't going to be a particularly long presentation. We'll wait till the end of the presentation to go through those questions and answer them and get through all of them. We can also unmute the audience at the end as well, so you can ask your question verbally if you want as well. Today's Lunch and Learn is presented by Matt Radford, our Director of Professional Services here at ShopView MES product team. Matt brings more than 17 years of experience in the manufacturing sector, spanning the automotive and aerospace industries, the tooling and information technology. His passion is finding innovative solutions to complex challenges and empowering manufacturing teams to achieve excellence. He graduated from the University of Windsor with a BA in sociology and holds a number of licenses and certifications, including an Agile Scrum Master and various other strategic and operational certifications. Matt has led and managed over 100 plus enterprise-wide projects of both large and small scope for various MES and ERP projects across multiple facilities and regions, delivering operational efficiencies, cost savings, and enhanced business visibility. He brings a wealth of real-world examples and pragmatic recommendations to companies of all sizes. And with that, I'm going to hand off this presentation to Matt. Matt, take it away.
Okay, thank you so much. And I'm seeing my video freezing, so I'm just gonna shut that down before we get going. Welcome everybody. Good morning, good afternoon, depending on where you are. I'm going to start with just a brief overview of our topic today, which is collecting real-time information right where the work is done at the point of manufacture. So three main elements. One, the ability to capture real-time data and process as it's occurring and react accordingly as it's occurring is the first piece. And really that data that you're collecting comes from two main places, and you're going to see me reference back to both of these as we go through the presentation. One being the people, so operators, supervisors, engineers, whoever has to manage, input, or monitor data as it's occurring. And then also data from machines. So that could be a molding press, that could be a CNC machine, that could be any number of connected devices like torque wrenches or Bluetooth calipers, whatever your flavor of the day is that you want to connect to, and kind of bringing those three things together. So getting that real-time information about what everybody is doing, when they're doing it, and what the machines are doing at any given time gives you that insight into activities and lets people adjust as it's occurring, which is going to be a common theme as we go forward here. Kind of gets rid of the delays of waiting for paperwork to be entered or waiting for someone to respond to an email or whatever the case may be. You have pure visibility into issues and items as they occur in your shop. How does that, I mean, that kind of applies to all industries, but specifically for the aerospace industry, I would say, typically aerospace has long lead times, complicated products, materials that are difficult to work with, lots of checks and balances and inspections and verifications. And it's not uncommon for like a 3-inch pad of paper to be shipped with the parts at the end of the day to get to the customer because, lots of things are tracked and managed throughout the build. So, high standards and precision and quality is why you would want to do something like this, as well as giving your engineers, your manufacturing engineers, your quality control teams, the ability to better manage within the requirements that are needed as you build and see errors as they're happening. And then also, being able to use equipment to connect and bring insights in from that side to, adjust and enhance efficiency and reduce errors, that kind of thing. So that's my brief introduction. Next, and I'm going to start with the benefits, and then we'll get into some of the challenges, and then we'll talk about some of the new items and emerging technologies and things that we're seeing within this space. But to start with, obvious benefit here is increased efficiency. So understanding when your work centers or machines are up and down and for what, and merging that with maybe TPM data or, checklists at the beginning of the shift, and they could be weekly, daily, hourly, could be your monthly preventative maintenance checks. Merging that information with your IoT connected machines to bring in process information like speeds, feeds, vibration, and then finding those correlations in the data to help move into a predictive instead of a reactive model. Is a big benefit to keeping your assets operating efficiently and running to standard. And if you get really good and you're one of those companies that has moved from predictive to prescriptive, maybe with that information, the system can even suggest how to go about addressing some of the issues that it's observing and coming up with. So that's one big element, is reducing that downtime and keeping things running. Also streamlining processes, because it's not just machine-driven work centers. In aerospace, there is a lot of manual operations, some more than others, depending on your process and your products that you're shipping. But there tends to be a good mix of machine-driven activities and also labor-driven activities. So giving production managers or supervisors, the ability to understand where everything is, who worked on what is next on the list, without them walking around with their clipboard and trying to find their whip on the floor, but knowing right away what the priorities are and who's working on what is very powerful. In most of these systems, you get a screen at a glance. You can see what everybody who's working for you is doing, what your machines are doing, how they're performing, whether that's OEE or other metrics that you review. We find that supervisors and managers can now spend more time focusing on improving those processes to improve efficiency instead of figuring out where things are and what's next and what's the priority, which is typical of a paper-driven environment. from like an automated planning standpoint, you can use this real-time information to use an APS system or to feed back into your MES or ERP to suggest changes to schedules. In some cases, companies have automated some of these changes. So as the feedback is being, received, the system is going through and creating a plan that's going to give you the optimum output for efficiency. And examples of that would be like, a job is taking longer than expected. It's going to be on a machine for another, 24 hours. You've got jobs that need to start behind it. Well, as you know, when it's going to finish, when the predicted end date is, these systems or people can go behind the scenes and better allocate their resources, move things to other machines, maybe subcontract if that makes sense, to keep the product flowing and keep efficiencies up, even though you're seeing a delay. So the degree to which people automate that kind of thing varies, but it is, something that is happening now in this space and really pushing efficiency forward. Second benefit, enhanced traceability. So I mentioned those big, thick paper packages. Excuse me. We do have some customers who have managed to get their process down to, reading an RFID tag on a pallet to know what it is and, where it needs to be worked on and give them information. So there's zero paper, as well as outside of the factory. So we're seeing more and more in the supply chain, RFID tags and gates being put up at dock doors. So, you can see in your system when something left. Is it on a truck? Has it been received at the other side? Is it moving through your subcontractor's process as you would expect? Definitely in the automotive world, this is happening. Companies like Toyota, Honda, they're pushing these gates and RFIDs. And when now in aerospace, everybody wants to get to it, but with the amount of paper, it's a challenge. But this is definitely one thing that contributes to understanding where and what happened to your parts, whether purchased or manufactured, as they're being made. And then compliance with regulatory standards. When you know how and where things were made and they were made under particular tolerances and within defined thresholds, you're able to demonstrate to auditors and to your compliance bodies, look, we followed our process. The results are where they need to be. And if they weren't, you can have full traceability on your reaction plan to that, whether it be rework or otherwise. And in aerospace, as everybody's aware, there's a lot of paperwork and there's a lot of requirements, and depending on your customers and the regions that you operate and the kind of things that you make, some of those regulatory standards can drive a lot of overhead in terms of gathering information, and even preparing for audits can be a nightmare. So when you have this digitized traceability in the system, it makes all of that quite a bit simpler. And we have a very good idea of where everything went and when it went there. And then obviously cost savings. People put systems in to make things easier, to simplify people's lives. But at the end of the day, we also want to make sure that there's a material savings to the business as a result of doing it. So, optimizing schedules, processes, running things in the most efficient way within your shop. Sometimes even using, nesting processes or material usage analysis to schedule things in a way that's going to reduce material scrap. And then also scheduling things in a way that's going to reduce labor waste, where you have people that either don't have work or don't have work quick enough or aren't scheduled to the optimum place to fully utilize those employees. So you can help reduce waste both on a material and a labor side by digitizing all of this. And then, ultimately, we want to optimize our resource utilization. And again, both from a people and from a machine standpoint. So, finance might be very interested in how people are working in actual hours as opposed to standards, which I find most aerospace companies are reporting currently. And then they just look at the labor variance to figure out at the end of the month, where was the waste? Well, when you're reporting in real time, when you're reporting actual times and looking at those times versus the standards, it can really open up a lot of discussion over, why is the margin a certain percentage on one part and not the other? How come this part that we thought was performing very well in the standard cost model, now in actual cost maybe isn't performing so well? Lots of discussions can be had as those costs are being accrued too, and we don't have to wait until the end of the month to get our financial reporting to understand how we were, managing our labor. Those kind of discussions can happen daily. We have some customers that, look at their labor variances every single morning and have their supervisors dig into it to try and keep people within the financial planning as well as the production planning of the thing that they're producing. So that's a very big benefit that can occur right there. And then energy efficiency is another one. Like, lots of people monitor different types of equipment, but especially in the newer equipment, being able to, minimize the amount of energy is going to help you both from a cost standpoint, but also from an environmental or ISO 14000 standpoint, where you can, demonstrate that you're working in a green manner. So on to the challenges, and the number one challenge, I would say, in aerospace when it comes to connecting all of these people and machines is data overload. There's a lot of old equipment, some equipment, spreadsheets, access databases. There's a lot of data out there to be brought in, and it can be a challenge if the mindset is, let's bring in all of the data all at once. You really need to strategize how you're going to approach the data that you have, what's important, what isn't, what's going to drive operational efficiencies and what isn't. What do you just not want to bring in is probably the most important question. Right. And then, once the data is in there, we can get into, how to use that data to automate, ensure accuracy, and make sure that what we're looking at is appropriate. Too often people bring in too much data and it causes issues. So be very strategic with that. Integration issues are another one. Again, most companies, unless you're very lucky and have a good capital budget, don't have a whole bunch of modern, brand new equipment laying around that is very easy to connect to. Now, modern equipment is quite a bit simpler to connect to. Most of them are made to do it through APIs and, basic plug an Ethernet cable in and you can get what you need, essentially. Older equipment, not so much. So you have to decide, how are you going to connect to it? Do we need extra hardware to connect to it? This is where we see a lot of our customers really need to sit down and come up with a plan on their key equipment as to, from an infrastructure standpoint, how are we going to connect? And then when we do, how are we going to integrate that information with other systems, whether it's an ERP or an MES, to facilitate compatibility, because maybe you're getting something that is data, but it's not sitting in a format that you can get to. And so IT has a challenge to overcome there to make sure that you can get what you need to get in the systems that you need it in. So integration, we find across especially legacy and older equipment is definitely a big challenge in adoption. And then my favorite, training and people challenges. Every company has this to some degree. Culture is a very difficult thing to overcome. And oftentimes we'll see customers not spend enough time bringing their people up to speed early, engaging them in the discussion, making sure they're aware of what is changing and why it's changing. And it's not just the operators on the floor, the supervisors, the managers, the engineers. Everybody needs to spend time understanding what's going to change, because at the end of the day, systems don't go in and just mimic what you're doing today. There is a certain amount of change on the business side that needs to occur, process changes and such. Also, we find workers maybe don't work with data all that often. And now we're asking them to be entering everything digitally, to be looking at dashboards and understand and comprehend it. And maybe that's not something they've done before. If you've been working a grinder for 20 years and you're an excellent grinder, and all of a sudden now we want you to digitize all of that information, that's a change in how they need to process what's coming to them, how they input information to move on. And that's something that needs to be taken into account. And then the last one on the list is resistance to change. And this, again, comes in various degrees depending on the company and even the plants within a company. But having a management team that's on board, that understands where we're going and supports it, is a very, very key point to pushing an initiative like this forward. If it's coming from somewhere and the people at the top aren't on board or don't understand it, you typically run into a lot of challenges with implementation. So people, all levels of the organization, is typically a challenge that we see across our customers. Emerging technology. So I've kind of beaten the connectivity thing to death, but that is an ongoing source of emerging tech, because as you connect to older machines, maybe you'll find, well, I want to hook up a PLC. Maybe you'll find, well, I want a Raspberry Pi. Maybe you'll find some other smart device that you can connect. But there's a lot of choices out there now, and a lot of thought that needs to be put into it. But it is, as time goes on, getting easier and easier to get some of these older machines on the network. And then once they're connected, now we can, make adjustments to things based on the fact that we're bringing data in and we know what's occurring. The second one on the list here, and I would be amiss not to talk about AI and ML. They are, really areas of experimentation, whether that's in the supply chain, whether it's within planning systems, and the like. There's a lot of experimentation happening in these spaces. And you'll see on my next slide there, I think that's an important element, is to experiment with these and see how can you use this information to, work within your business in a way that's going to drive a positive business outcome. Putting AI in to predict material usage and, not driving that forward into other areas or making sure that everybody is using the information is a waste of time. So I think the application in these areas varies greatly between companies, but it's definitely something we're seeing more and more companies experimenting with. Augmented reality and VR, there's really two main ways that I would say these are primarily being used in aerospace at the moment. One is from a design standpoint, where, let's say you're designing a part, you can visualize the part in real life. You can see how it fits together with other parts with like a virtual rendering. And then even in cell design, like some of the new integrating companies, they'll set up, they'll send you a CAD file that you can view in like a VR or an AR overlay and go out into the plant and actually see where the machine is going to sit, make sure that heights are right, safety things are in place, make sure that, there's no unforeseen issues with where it's going to be, or there's a post in the way, whatever. So that's kind of on the design side, what we're seeing. And then training for operators is another one, right? Especially if you're doing a complicated assembly with a lot of pieces, seeing where they're grabbing, highlighting it red, showing them where to put it on the actual assembly is coming into play more and more for error proofing and also for general training without having to use the typical follow this paperwork instruction route. So that's sort of where those are coming into play. And then in conclusion, just some parting thoughts. One, real-time data is very, very powerful if you use it right. So I'd encourage everybody to get on the real-time data train and embrace it. It is what you use to manage your operations more effectively and to stop issues from progressing before they become big issues. And then I'm going to throw another automotive tidbit in here too, because we talked a lot about automation, and over automation can be an issue. You don't want to approach something like this thinking that you're going to automate everything and the system is just going to run. But the Judoka principle of integrating human intelligence with automation is really something to think about. People have a place in the process, and at the beginning and end of every great system is a human. So where they fit in between and how the humans interact with the technology is a very important thing to consider. Third point, experimentation. Like I said, there's no one way to do any of the items we talked about. There's lots of ways to approach it depending on your company, your products, your customers. But stay creative and stay, experimental and do the R&D, try some things, pilot some things, do your research, because companies that are getting ahead, they're dabbling in these technologies. And then strategize is a big one. I can't overemphasize how important it is for the business to understand that making a change like this is going to change virtually everybody's job in the factory and how they work with information. And it needs to be treated as a very big strategical shift. So things like data overload, integrating things, training. If you don't have a strategy to address those items, it's very difficult to successfully implement this kind of system and technology. Okay, so that is my spiel for the third session. Any questions?
At this point, feel free to use the chat feature to type out your question. We have one waiting for us, so I will ask that, and Matt, if you can answer it. And while he's doing that, if anyone else has any questions, go ahead and put those in. So Matt, this one that came in is a two-parter. So it asks, what strategies can companies implement to effectively train their workforce on these new real-time data collection technologies? And the second part of that is, how can they address potential resistance to change?
Yeah, so I guess for the first part, a good strategy is early engagement. So you want to bring people in and have a cross-functional group so everybody is aware of the changes that are coming. And then regular feedback throughout the process is essential, right? You need to listen to the people that are going to be using the system and understand what the challenges that they're facing are. And once you approach things like that, typically people open up a little bit. They become more open-minded. They adopt what you're asking them to do. The worst thing that you can do to anybody involved in a system change like this is drop it on them with very little engagement, very little knowledge and sharing up front, and don't listen to their feedback and just expect them to follow the steps A, B, C because that's what you're asking them to do. That is not a good approach. So I think, the earlier that you can bring in the people and give them the information and show them how things are going to change and start to elicit their feedback and then act on the feedback is key. And then the second part about difficult employees, it's kind of the same thing. Like there are some employees that, they're set in their ways and they're never going to want to change. And that'll be a small percentage of the overall. But for the vast majority, if you listen, if you communicate, and if you act on things that make sense that you should act on, that they're bringing to the table, they'll feel more like part of the process. They'll feel properly engaged, and you typically end up with a better implementation and result. Thank
you, Matt. No other questions have come in, so I believe we are all set for this session. I want to thank everyone for attending today's Lunch and Learn. This is our final presentation in a 3-part series for aerospace manufacturers. We will have this replay available that we will send out to everyone after this call, as well as send out the replays for the other 2 if you were unable to attend those. And if you would like to continue the conversation, learn more about us, CAI software, as well as our ShopView MES solution, you can reach out to us directly. Our email and website are right there on the screen, info@caisoft.com, or visit us, caisoft.com/shopview. And we'd be happy to chat more about what you guys are doing at your company and how we could potentially assist you. Thank you so much for attending today. Everyone have a great day.